Hello, everyone.
Hello.
Okay. So we'll start our Fridays talking about project stuff. And today I'll just introduce the project, what the overall goals are, give you an idea of what your first deliverable is supposed to look like, which I think is due on September, well, let me check, due on September 11th. On your assignments page, everything is broken out into quizzes, homeworks. First one is due September 7th. And then the first project is due September 11th. Now, these are 7 project deliverables, all pertaining to the same single project. And the idea is to start to teach you as you go through the project, not just about object-oriented paradigm, not just about how to design a piece of software using the object-oriented paradigm, but to start to work on software engineering processes. Engineering is a discipline. All engineering is a discipline, and there are processes by which you produce a product. And so we're introducing you through the project to these processes. The process that we'll use is a bastardized version of Agile Scrum. Agile Scrum is actually a team-related activity, and it has a lot of team building factors built into it. But here, what I'm doing, since this is an individual project, is adapting some of that to your individual work. So the process by which you create the project will still follow the the Agile-like methodology to the degree that it makes sense. So that's the goal, is to give you experience, practice developing using Java as a specific programming language, practice thinking in the object-oriented way, practice developing a relatively sophisticated piece of software. And by relatively sophisticated, you know, you're one person, this is one semester, so it's only going to be so big, as opposed to when you get into SC300, you'll be in teams of 4 or 5 working for one semester. Those of you in the EECS programs, when you get into Capstone, you're going to be in teams of 5, maybe 6, and you'll have 2 semesters to work. And then, of course, when you go into industry, you might be on projects that last several years. So the idea is to start to get you to think about something bigger than the kind of assignment that you're doing in the homework, where it's a one and done kind of thing. Learning to build software that is designed to be extended is quite a skill. And you get a little taste of that here, because you're not going to build all your software all at once. You're going to build it in pieces with the idea that you know you're going to add on to that piece later. So you design it in such a way that it can be extended. Learning to work on software that has already been partially built, or actually has been completely built and you're revising, is very common in industry. If you get a job as a software designer in industry, you almost certainly will not be building something brand new from scratch. You're going to be taking existing code and modifying it. That's a very common thing. So hopefully the kinds of things that we're teaching you here are designed to help you, number one, get into this the idea of complexity. Number two, get into the idea of the software isn't there just to get the job done. The software is there also to be maintained. It has to be someone has to be able to understand it. Someone has to be able to modify it. In this case, it'll be you. And you may have already experienced this in a previous programming course or in your hobbies. You program something and then you go back to a month later and it was a, what the heck was I doing moment, right? So the idea is not to have those moments. So along the way, you're not just building software, we're introducing you to the software engineering processes, software engineering, software development, software test, software documentation, these kinds of things. Whenever you develop software or deliver software, it's not just the software, it's the software plus the documentation. The amount of documentation in the Agile Scrum world is minimal. Nice. All right, so I've got these overall description. Let's talk about that. I want to focus on these 4 major project requirements. These are things that your project must include. Now, your topic can be about anything. I encourage you to pick something that you're interested in, something that has personal value to you. Number 1, so that you'll want to work on it. And number 2, I hope when the semester is done, you get to keep your code, use your code, expand your code, as opposed to something that you just did for a class and you never see it. Useful code is something that you're going to want to keep. And so I hope that you create something that you can use when you're done with this course. In addition, if you're happy with your project, you like the way it came out, you can keep it in basically build a portfolio of software. So when you start to do job interviews, either for internships or for full-time positions, you have examples of your work, which they will be happy to look at. And you can post these things on ERAU Commons and things like that. So you have a repository of your work while you're an undergrad that will help you get a job or help you get into grad school. Okay, here are the 4 major requirements. You have to have all user interaction going through a graphical user interface or a GUI. The examples that we've done so far are console input and output, and we're not going to stick with that. It has to be graphical user interface. And not only that, it has to be graphical user interface designed with Java FX. Java has had several iterations of how they do their GUIs. They started out with Java AWT, which I believe was Abstract Windows Toolkit. Nobody liked it, so they changed after a few years to Java Swing. They kept that for a decade or so. Most people didn't like it. Now they're doing Java FX. Be careful when you're developing your code and you need some help online and you start to Google around and you're searching for how do I do this or that with a graphical situation. You know, how do I put in a text field? How do I get the values from a text field? How do I make rectangles inside rectangles? Whatever you need to do. Make sure you Google Java FX, because otherwise you're going to get AWT responses or Swing responses, and the last thing you want to do is use an example from AWT or Swing, and you certainly don't want to include any AWT or Swing graphical elements in your code. If you try to make them play with Java FX, they normally don't play well, and when I look through your code and grade it and I see a AWT or Swing element, then I'll, takes a good hit off of your project. The GUI will take a little while to create, only because interfaces, input-output, is always the ugliest part of any programming language. And you can spend hours and hours and hours making your GUI beautiful. And I would encourage you not to. I would encourage you to make your GUI as plain and functional as possible. You can make it beautiful after the semester. So that's where some of your time will go. The second requirement, you have to do some kind of file I/O. Now this is usually a trivially met requirement, okay? This can be as easy or as hard as you want it to be. A lot of students like to do games, and I encourage you, if you're gonna do a game, you can meet the file I/O requirement super easy just by saving the top score. There's your output, and then if I'm playing the game, I can look at the top scores. So there's my input. So you get file I/O that way. It can be that simple. Sometimes people are going to use file I/O to set up situations in their software. So you might have some people in the past have done like dungeon crawler games, text-based dungeon crawler games, and there's always a boatload of content in those. I recommend that you set up your code not where all of your room descriptions and things like that are hard-coded in the code. Put them in data files, and that way you can extend your dungeon by just extending the data files. and then have your code smart enough to bring those all in. So again, that's a fairly easily met, right? If you're just going to go with bare bones file IO, that's pretty trivial. The third one is that you have to have at least one case of exception handling. So exception handling is, you saw when I had the examples the other day, and I was doing console input, and the program expected me to give it a numeric value. I gave it a non-numeric value. I gave it a string, and the program crashed. That's an exception. Whenever the program fails, that's called an exception. And the idea behind exception handling is in Java and most modern programming languages, you can actually handle the exception. So when the exception occurs, it doesn't kill your program. Instead, you put in alternate instructions to get around the failure. And this one is also easily met. If you have any place in your program where you are allowing free-form user input, like enter your name, you can check to make sure that if you expected to get a string, you got a string. If you expected to get a number, you got a number. And do the exception handling there. And you only need to do it in one place. Basically, you just need to show me that you know how to do it. Now, I do make an exception. It cannot be related to file IO. And the reason is a lot of the file IO routines that come with Java already require exception handling. And so I want you to create your own, but you only have to do it one time in your code. Now, if you're a really good, robust coder, every time you get user input, you check every time you do exception handling. Okay, so it cannot be related to file IO. And then the fourth requirement is that you have to do inheritance. And this is showing that you actually are taking advantage of the object-oriented paradigm. Remember, the object-oriented paradigm is built, programs are built as collections of classes, which then create objects, and the objects interact with each other. That's how the computation gets performed. And as we saw with the sheepdog game, the idea behind inheritance is you have a generic version of some class, and then you extend that class in a non-trivial way. So I need to see one case of inheritance. Now again, the inheritance cannot be related to the GUI stuff, because once we get into the GUI stuff, you'll see that you are required to use inheritance to create your GUIs. So I want something separate than that. I want something intrinsic to your project. So those are the big four. Other than that, anything goes. Pick your own topic, do what you want. I will approve your topics, of course, just to make sure that they're appropriate for the course. And I'll talk about that in a minute. But those are the big four. Now, if you meet all four of those, you have gained nothing, because that's just the basic minimal requirement. That's just your ticket of entry, basically. If you meet those four, you gain nothing. But if you miss one of them, each one you miss is minus 50 points. The whole project is worth 300, so minus 50 is a pretty big hit. The reason I do that is, again, because these are the basic four requirements that just give you basically permission to do a project. Formatting, you'll find in the commercial world, is important. Following basic requirements, you'll find in the commercial world, is important. You can get 0 credit, meaning dollars, from the customer if you don't meet one of their basic requirements. I'm pausing here for question. Okay. The formats. Now there's 7 deliverables, P1 through P7. I will give you the formats. I will give you the shell documents, the templates to fill out. And again, if you don't turn in your documents in those formats, I won't grade your work, period. And again, that's because that kind of thing is important in the real world. Let's get used to it here. I was on a team that was submitting a proposal to the NSF, and it was about a $3.5 million proposal, and it was returned without review. They didn't even look at it. And the reason is these things have, 6 or 7 or 8 sections. One of the sections was not in the proper format. So the whole thing was rejected without review. So that's the kind of thing that I'm talking about in the real world, and that's the thing I'm talking about here. Now, having said that, I'm giving you the formats, I'm giving you these forms, and I will give you as much feedback as you want to help you achieve this. So it's not something completely out of bounds or unachievable. All right, you can pick a topic that you like. And I want you to pick a topic that you like so that you're invested in this project. I do not want to, I will not assign project topics to people because I don't want you to be, Garfield's making me do this. Do something that you want to do, something that's interesting to you, something that might be useful to you. If you're in a club or an organization and they need a software tool for something, hey, this is a good chance to give it a try. If you're in a fraternity or a sorority, I've had people who are RAs do software that help them do their job as RAs. I've had people that were equipment managers for the ERAU sports teams build software that helped them keep track of the equipment. Now, whether they use these things when the class was done, I'm not sure, but that doesn't matter. The point is they were trying to create something useful. And if you can walk away from this class and actually keep using your software after the class is done, that's the best. That's what I hope happens here. A lot of students like to do games, and I am going to forbid you from some games. And there's the list there. Battleship, Tetris, Othello, chess, blackjack, poker, Sudoku. I need to add Hangman to that list. And the reason is, you can thank students in previous semesters, students who picked those topics had a very high rate of plagiarism. There are, you can Google it right now if you want. Google Tetris Java and you'll find about 80 different Java programs that will do Tetris up on GitHub, or Blackjack, or Othello, or Battleship. So the idea here is I want to take temptation out of your hands. I think normally the way this works is students panic. They don't go into it saying, oh, I'm just going to copy mine off the web. What I've seen seems to be, oh my God, it's the end of the semester and I'm way behind and here's some stuff online. It's not hard to catch because of the coding styles. So I'm just taking that off the table. In addition, a lot of those are boring projects. Blackjack and poker are hideous projects. I've had lots and lots of students that like to do them over the years. And even the ones where they're creating their own usually created something that was fairly substandard. And the reason is it's just not a good topic for a product, especially the inheritance portion. Okay, questions about that, topics. Now, go ahead, I'm gonna wait until there's a question and see if there's a question. Okay, if you have a question, oh gosh, I don't know, is this a good topic, bad topic, that kind of thing, by all means, send me a message in Canvas and ask me. I've already had people doing that. And you can always take the P1 deliverable, which is your proposal, and upload it early. And I'll periodically take a look and see who's uploaded theirs and then give feedback. And then I will not grade it until it's after the due date. So, unless you ask me to. And so you have an opportunity to keep modifying it based on our discussion. Here's what I tend to find, by the way. I tend to find that I'll have 1 or 2 students a semester who are proposing a topic that I think is too simple and won't make a good project. It would be really hard for them to meet those 4 basic requirements based on the topic that they choose. I'll have more students, 5 or 6 or maybe 10 each semester, who are picking a topic that is much harder than they think and will take much more effort than they think. And so I have to negotiate with them and try to convince them to pull back. and reduce the scope of the project. If you want to do a project, remember, you're one person, one class, one semester. If you want to do a project that's really sophisticated, that's fine. But what I would recommend is you and I come up with a way for you to get partway through it where you're meeting the goals of this course. And then after the semester is done, then you can finish the project. That tends to work out. Now, I don't want you to set yourself up where there's no way you can get this thing done and you get a big hit on the final project. Right? Nobody wants that. Right? Okay, the deliverables. 7 deliverables, P1 through P7. The first one is the proposal, and it's due September 11. And then the second one is not software. It's a software design document. The proposal is going to be very short. We're at software design document where you first just flesh out, you don't have a design yet. You're just fleshing out the problem. You're fleshing out what the software is supposed to do. You're describing in great functional detail what your software will do. And I urge you to be serious about that. That's why that effort estimate is 12 hours for that. Think through great functional. Imagine what it's like to use this software. What can it do? What won't it do? Imagine what has to happen, not in terms of a solution, not in terms of what the code is. You know, you're not writing code yet, but in terms of what has to happen to make the user experience happen. Yes, it's difficult to think through that until you've done this 3, 4, 10, 50 times. Let's do the best job you can with that. And I will give you feedback. I give quite a bit of feedback on P2 and P3, both in terms of writing style and in the specifics of how you're phrasing things and what you're expecting your software to do. So we get this functional description and something called user stories, which we'll talk about. The software methodology that we're using here, again, is the Agile Scrum, but adapted for individuals. And part of Agile Scrum is to make a list of all the program functionality in the term of a user story. So I'm going to ask you to put in user stories. This will also help you schedule your work. The third deliverable, still no software. The third deliverable, now that you've, in the second deliverable in P2, you've defined the problem. In P3, you're defining the solution. And in addition to the solution, you're going to describe, okay, here's what the classes are, here's what their job is. You're going to give a UML diagram, and we'll talk about that. That's a unified modeling language diagram that graphically shows how the classes relate to each other. And in addition, you're going to come up with requirements and test cases. And then after the P3 deliverable, then you finally start writing code. So if we look at the schedule, P1 is September 11. P2 is September 28. P3, so between P1 and P2, you've got 2 weeks. So I'm saying it probably would take about 12 hours. That's my guess. 12 hours spread over 2 weeks. Between P2 and P3, I give you a lot of time, basically 1, 2, 3, basically 3 weeks with a couple of weekends thrown in there. And I'm estimating that at about 12 hours too. And the reason is P2 and P3 is where the real work gets done here. If you do a really, really good job in P2 and P3, then the actual production of the code becomes much, much easier. It's still going to be annoying sometimes because, you're unfamiliar with Java, but your goal is to make the coding boring. Your goal is to be so well designed going into this that writing the actual code is not that difficult. So that takes us all the way up to October 21 for the P3 deliverable, and you still haven't written any code. I encourage you to work this way. I will keep encouraging you to not write code until you've got a design down. Nobody ever built an airplane until they designed it first. Nobody ever built a truck until they designed it first. Same idea with software. Why should software be different? Don't build it until you design it. You might build some little test toy software just to see if an idea you had might work. That's okay, that's different. But as a rule, I'm pushing off this coding. Then what we do from October on, you have P4, P4, P5, P6, P7. They're all about a week and a half to 2 weeks apart. And each one of those, P4, P5, and 6, is basically nothing but the software. Finally, you're doing software. So you're giving me a software drop, and then you're also going to give me some documentation that you've actually tested the software and it works. Now, the first software drop you do, that's not going to be your whole project. It's going to be a piece of it. You're going to say, you're going to pick and choose what parts of your functionality you need to have done by P4. You get to choose that. And then by the time P4 is done, you'll have that much software done and tested. And then P5, you extend it. P6, you extend it. And P7, it's finally done. And then you'll turn in all these things. Now you'll notice I'm putting down here estimates of 8, 10, 10, and 10. Those are all spread over 1.5, 2 week periods. So, you know, we're looking at maybe 5 hours a week kind of spread. It is entirely reasonable for that to happen if you did the initial planning and design properly. If you're, you know, I'm asking you, this 12 hours in here is critical. I encounter all kinds of students in this class. I've had hundreds and hundreds and hundreds of students in this class over the years. And some really take this to heart, and some really turn in a really good design document and a good description. And they tend to be very happy people at the end of the semester because their coding is just rolling right along. And then I have other people that don't appreciate the importance of that, and they are very unhappy people at the end of the semester because they are neck deep in code that doesn't work. They don't know why. They don't know how to fix it. And usually it's because they've coded themselves into a horrible situation where they made life much harder on themselves through the lack of planning, the lack of design. And I will tell you, as you're coding, of course, you're going to come to me for help. You're going to go to Dean Laga for help. You're going to go to Robert Apelian for help, maybe Michael Fornito for help, maybe each other for help. If you ask any one of us for help, usually the first question we ask is, okay, where's your design? Oh, it's in my dorm. Oh, it's on my other computer. I've got it somewhere. It's on the web. Okay, go away. Come back when you have your design, then we can talk. Because I cannot fix your coding problems as a general rule unless I understand the design. It's very difficult. And it's important for you to have that design in place. When we're in a face-to-face setting, every semester, after P3, all the students have the design, and then most of the rest of the semester is, even in class time, they're coding in class and I'm there to help them. That's how this course runs in a face-to-face situation. And, you know, I kind of chuckle at these guys all the time. I'm like, everybody's programming, everybody's coding. Nobody has their design in front of them. And they're like, oh yeah, you're right. I was having a hard time programming this. Well, of course you are, because you're not looking at your design. Okay, so these are what the project deliverables are. And you can see the timeline on the schedule that is posted in the, where are we here? Here you can see this schedule. All right, so these little rapid coding blocks are called sprints. Your first sprint is from P3 to P4. That's from October 21 to November 2. That's about 2 weeks. November 2 to November 13th, just under 2 weeks. 13 to 23, just under 2 weeks. And 23 to 7, right about 2 weeks. So the idea is, and we'll talk a lot about this, right? We're going to talk a lot. That's why every Friday we're talking project stuff. Go ahead, Sam.
So I just want to get a better idea of like the sprint projects where you're talking about P3 to P4, P4 to P5. These are like codes that aren't truly complete, but they're compilable. Like you can compile it, you can see what the student's trying to do for the project.
Exactly.
And you understand what.
That's exactly right. Yep. So what you're doing is you're creating a functional code, right? Not all of the functionality that you want in your code is there, but the code is functional in that it will compile and it will run, and it won't do it won't do everything that you want it to do, but it will do something. You know.
So
yeah, go ahead.
I guess my question would be then, like, let's say somebody was trying to, I'm not gonna say try to make it like a cheap way, but try to make something that's like fairly simple to what they planned, but it doesn't have enough information for you. Like, I was wondering how you're gonna handle that situation of like, let's say they wanted to do it for all the way to P6 or P5 more or less. Like they wanted to work to P5.
Right.
And they said, my code is complete as P5 because I put so much information in here. And I think, you know, I don't want to write 600 lines of code or whatever. How do you handle that?
Well,
do you tell the student, well,
right.
You know.
So that's what's going to happen in P2. They're going to tell me everything that this code does.
Okay.
Okay. And if it happens to actually do all that by P5, good for them. Take the month off. But if they're just telling me that it does that, I can clearly see, look, you said it was going to do, I'm going to ask for 12 specific things, right? You told me it was going to do these 12 things. It only does 6. So don't tell me it's done.
Got it.
Right. It's a self-monitoring system. And the idea, by the way, part of the idea here is you'll see that the part of the beauty of the system is you yourself will be able to tell, am I ahead of schedule, am I behind schedule? And I can also see that just because you're telling me, look, this thing is going to do these 12 things. And then on the P4 deliverable, let's say, you're going to say, okay, but now it does number 1, 2, and 3 by P4. And you're going to literally have test cases that show that, at least for some. We won't fully test the system because that'll take too much time. And then by P5, it does 1, 2, 3, 4, and 5. And by P6, it does 1, 2, 3, 4, 5, 6, 7, 8, 9. And by P7, it does all 12. But you're going to identify those things that are done. And if you tell me that number 9 is there and it's not, it's really obvious.
Okay, then. All right, cool. Thank you.
Oh, sure. More questions? Okay, I'm not going to go over the topics list too much. Is this it? Sample topics. I love the elevator study. I've never had a good elevator study come out of the class yet. I like traffic studies. They can be a little tough. Queuing models are not that tough. People have done particle physics simulators, agent-based models. Some people have done some beautiful agent-based models. Genetic algorithms or other machine learning, those are all fine. Someone that, by the way, an agent-based model is this. If you know the, virtually all video games are agent-based. An agent is just a decision maker, an independent decision maker inside of a simulation or inside of a gaming world. So a non-player character in a game is an agent. And if you're doing the, Run from Zombies games, all the zombies are agents. And a few years ago, someone did an agent-based model where it was a village, and the village had to have, everybody in the village took on one of 3 roles. They were either out gathering, hunting food, or out growing food, like, gathering food, or they were, I think, defenders of the village. And then he ran the simulation like 1 million times using genetic algorithms to figure out, like, if you wanted to have a village of 500 people, how many should be hunters, how many should be gatherers, how many should be defenders, and came upon the right ratio that allowed the village to thrive the most. You know, that kind of stuff. It was kind of interesting. I thought it was a well done project. In addition, Human Factors has provided these as just a really quick list. This was just a really quick email exchange between myself and Professor Dougherty. And some of these were, I thought, very interesting. The good news here is if you take these on, you can earn, but I'm going to be very strict with this, up to 30 points extra credit. But there's probably a lot more work involved here too, because you're going to be working with a human factors advisor or faculty member, and so that you're actually making a product for them. And, you know, for you to get the extra 30 points, you know, I'm going to need them to sign off that, yeah, you actually produced a product that's usable in their labs or in their classrooms. So I think it's a great thing because it's an actual useful tool, and it can be used on campus by other people. And if you're a human factors student, you know, this may be something that you could use in your research someday. So I think that from that standpoint, it's great. What I don't want you to do is like, yay, 30 points extra credit, and then flood to it and then just create crap products that you're not really interested in, right? The reason the 30 points is there is because there really is a little bit of extra effort involved in those topics, I think. Now, if you want to do those topics and not worry about the 30 points of extra credit, by all means, take them. They're still fun. I've had people do memory games before. In fact, two semesters ago, someone did a memory game that was used. What they did is they created a concussion tester. You know how in sports they take people off to the sidelines and give them the concussion test? They did a concussion tester, and part of that was a memory game where images would come up, and then they would have another list of images that came up, and sometimes the images that were in the first list showed up in the second list, and sometimes they didn't, and the person had to say, yes, that was in the previous list, or no, it wasn't. And they also did the same with words. Those kinds of things are fun. You can make those kinds of games pretty straightforward, and they can be useful. Same with memory stuff. You can do, if you look up unconscious bias, you can do unconscious bias tests. I had someone do learning sign language last fall. So the learning sign language was you would go through training, and they would do the standard pictures that you get of the different letters. And so those pictures were up with the letters, and then after you go through and learn, then it would quiz you, and it would give you a picture and ask you which letter it was, that kind of thing. So those kinds of things are viable projects. But like I said, don't just run to it for the 30 credits. You know, the 30 credits does mean there's a little bit of extra work there if you do it with the faculty. If you just want to do it because it's a cool thing to do, then do it because it's a cool thing to do. Okay, let me talk about the first deliverable for a little bit. I'm going to give you some good and bad examples. So here's an average example. And the description was good enough. Now this was a problem. This particular project was a little too simple, and so I had to work with the student. And man, he was fighting me to make it more complicated. By the time we got to the end of the semester, this was actually a legitimate project, and it was kind of a logic game, you know, where you put in a guess for I think it was got here, safe with a keypad. You put in a guess, and it tells you things like how many numbers you got right, but not where they were, not which numbers they were, that kind of thing. But the reason this is average, the description here is okay. I didn't like the project, but the description is good enough. And then I'm putting these online for you, by the way, too. But then this was, I don't know, this was kind of not, tell me functionally what the GUI is going to do. Okay, the GUI is going to be there. In this case, it's going to show an image of a safe. It's going to allow the user to make attempts at opening the safe. It's going to give feedback, that kind of thing. File I/O is pretty straightforward. If you're doing a game, just say, I am saving the high score, and a user can view the high score. That's easy. If you're doing other forms of other usages with files, then have that description too, but again, say what it is. Try, throw, catch. This is called exception handling now to make the language more consistent with how I use it in the course. Exception handling cannot combine numbers and letters as the user cycles through the keyboard. That doesn't make any sense. Basically, your easy get out of jail free card for exception handling, if you have any kind of user free-form input, you will verify that the user free-form input does not contain invalid data. I could almost give you this document with that typed in there, you know, is how often that'll work out. And then type of say for inheritance. Technically that would be inheritance, but I thought it was a pretty trivial difference, so I convinced him to do some other things. But the idea is, tell me where your generic object is and why you have specific objects. So let's look at a better version. Where'd it go? I'm going to close this out. Let's see, here's the good one. Oh, much longer. Now it doesn't have to be this long, but if you read through and see why it's this long, this person is really thinking through the functionality of what they want to do. You can input what he's saying. This person, people who do gaming can come up with, I've seen some interesting topics. So this person, in the game that he likes to play, Star Citizen, you can trade, you can accrue cash, spend the cash. More and more games are getting this way, right? And so he wanted to come up with some software that would help him make the best trades or the best deals and open up, what's he talking about? Efficient trading routes. They could be efficient in terms of fuel. They could be efficient in terms of the most net profit that you can make, or they could be efficient in terms of maybe time spent or something like that. So right away, he's got this notion of, oh, I'm trying to do a similar thing that has some variation. I'm trying to get efficiency out of my trades, but based on different criteria. That sounds like a generic trade strategy and specific trade strategies. So right away, he's got inheritance built into the idea of this thing. A lot of times your inheritance is not going to be physical objects. For example, we did the sheep-sheepdog game, right? In the sheep-sheepdog game, we said, okay, the animal is a generic animal, and then the inheritance comes when we extend the animal to a sheep, and we extend the animal to a dog, and now we've got two different kinds of animals. That happens a lot. That kind of inheritance is a natural thing. You've got a zombie game where zombies are chasing people. Have a generic zombie, have a fast zombie, a slow zombie, a zombie that can go through walls, you know, a zombie that can teleport, right? These are different behaviors. That's a natural fit. But sometimes you can have non-physical objects to meet your inheritance need, and strategy is a great way to do it. So one of the things that frustrated me when people kept wanting to do blackjack games is they kept saying, well, the cards are inheritance. Here's the, you know, a generic card, and then I've got clubs and diamonds and hearts and spades. And no. They're still the same. I don't care. That is not inheritance. What you want is strategy. Oh, you can have in blackjack, you have a betting strategy, a generic betting strategy, an aggressive strategy, a timid strategy, right? So now you've got different kinds of strategies. So anytime you guys are doing any kind of a simulation or a game, at least consider that the strategy by which the agents are operating might be where you get your inheritance. And then, oh, good description of the GUI, good description of the file IO, good description of the exception handling, and then good description of the inheritance. It does not have to be this long. Like I said, your file IO can be as simple as I'm going to save the high scores and the user can view the high scores. That can be that simple. Try, throw, catch can be, the user will have to put in freeform input here, and I will use try, throw, I use exception handling there. Again, I've changed this to exception handling because try, throw, catch is another name for that, and sometimes students were confused. Let me show you a poor example, and I think hopefully you will agree this is a poor example. Now, I'm not big on length. Longer descriptions does not always mean better descriptions. In fact, sometimes longer descriptions mean worse, but there's a point of diminishing returns here, right? This thing, it was way too short. It's a 2D survival game. Okay, I don't know what 2D is. Who knows what 2D is? Anybody? Two-dimensional, two-dimensional. Thank you, Evan and Gabriel. How do you know? How do you know this person meant two-dimensional in that specific usage of the word? You think you know, and I believe you're correct, but that's not how engineering works. So 2D. Okay, it's a 2D survival game. How many people know from that word what you're surviving? Zombie apocalypse, boredom, the class. The user will control a character that will collect materials to defend themselves while also having the option to upgrade themselves. What are these materials? What are these mysterious materials? Defend themselves from what? Upgrade themselves to what? You don't have to have the whole game here, but you understand what I'm saying? Give an idea. Have a better idea than this. If you're not willing to invest in thinking through the idea of it, you will have a miserable end of semester. Way too vague, right? Way too vague. And I'm going to hammer on you guys throughout the semester about clarity of writing and how not to be vague. In engineering, vague is horrible. Vagueness, we try to get rid of as much vagueness as possible in engineering documents because, again, when you deliver a product to the customer, you really want to be sure you delivered the right product to the customer. If they are vague in their description of what they want and you are vague in your description of what you will deliver, I promise you, you will go to court and get sued and nobody gets any money except the lawyers. So the same thing happens here. Keyboard inputs, GUI, keyboard inputs. Well, wait a minute. First of all, is the GUI a black screen? Do I just put in keyboard inputs blindly and I don't know what's going on? Tell me what the GUI looks like, basically. This will be a top-down view of the area of play, blah, 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 showing the character and the materials and the mysterious things that we're defending against. Control will be using the arrow keys for what? I don't know. Arrow keys. I guess he's doing upright left down. I guess. And some other keys. Car keys will be used for pausing and resuming the grade. Computer respond to inputs by moving the character. That's not file IO, right? So you really want file IO is going to be I'm saving to a file and I'm withdrawing from a file. By the way, what would be a beautiful way to do file IO in this game? One is, of course, you can save the high score. But for file input, what if you had multiple levels to the game? Rather than creating your multiple levels hard-coded in the classes, file for level 1, file for level 2, file for level 3. That's the way to do it. Try, throw, catch. User input keys have no function. That's not really try, throw, catch. Again, what you're going to want there is free-form input. And then this is actually good inheritance. Different villain classes based off the main class villain. That's legitimate inheritance. So give me, again, you're not going to have this this thing designed yet, but you should have a good idea of the functionality that you want to do. And then I'm asking you for for your time estimate here. I don't believe that took 3 hours for a minute. Maybe it did. But I'm going to choose not to believe that. What I'm going to do after homework 1, and actually after every one of these, is, if I haven't mentioned this already, I'm going to put up a poll and you tell me how long it took to do the work. So after homework 1, which is due Monday, I'll open it from like Monday night to Tuesday night. So you can do a poll and tell me how long it took. If we choose a topic, do we have to? Anna Maria, I often have people change topics, so changing topics is not a problem. However, if you start to get late in the semester and you want to change topic, I get really nervous, and I will not restrict the student from changing topic. But if it's like 3 weeks before the end of class and you want to start over, probably doing yourself more harm than good. But it's very common for me. I'm going to guess 5 of you are going to change your topics. That's my guess. Is there a grade reduction for changing? Absolutely not. Nor do you, let's say you did P1 and P2 and then you decided to change your topic. You do not have to redo P1 and P2. other than the stuff in P2 always has to be current with what you're, at the end of the semester when you turn in your P7, it has to be upgraded to the latest version of your software. In that sense, you have to redo it, but you don't have to, you know, literally redo P1 and P2. Sure. And again, I'm going to guess maybe 5 of you are going to change topics throughout the semester. Earlier is better, but you know, you don't always have control over that. If you come to me, like I said, 2 or 3 weeks towards the end of the semester and you really want to change, I will not forbid it, but boy, will I try to talk you out of it. Okay. Anything else going on here? We're over time. I will give you lots of examples of writing, and I will have some class discussions that are basically all about writing. And like I said, I will give you some feedback. So please pay attention to those. You will not, I cannot impress upon you enough how much your clarity of writing will impact your professional life and make your professional life much more profitable, fun, and successful, and your academic life. So I will stress that in this class. Okay, quick questions before we go. We're 2 minutes over. I'm holding you guys up. All right, then have a wonderful rest of your day. Good weekend. Happy coding. I will see you on Monday.